Hello everybody, this is Professor LaShan and I'm going to go over the examples in section 2.1 from our textbook, and I'm starting on page 43 following the course lecture notes, and it asks us in example 2.1 on page 43 to construct a frequency distribution for 25 Army inductees who were given a blood test to determine their blood type. The data set is, and it's got various blood types A, B, and O. So what we're going to do is we're going to construct a frequency distribution here. And so we've got the class, we've got the tally while we count up the blood types for. Counting up then the tally marks, we'll have the frequency column, and then we're going to have a percent. And again, this is example 2.1 on page 43. So the different types of blood type are A, B, O, and AB. And if I look at the data set on page 43, I'm just going to go across. The first one is A, so I'm going to put a tally mark. Then a B, put a tally mark for B. Then another B in the first row. Then AB, and then O. Going to the second row, I have O, another O, B, AB, and B. And then going to the third row, I have B and B, so there's 5, and another B. I have O, A, and O, so O, A, and O. Then going to the fourth row, I have A, O, O, so A, O, 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 A, B, so another O and then an A, B. Going to the last row, I have A, B, then A, then O, then B, and then A. So if I count up my frequencies here, then I'm going to see for the tallies, counting the tally marks, I had 1, 2, 3, 4, 5 A's. I had 5, then 2 more, 7 B's. I have 5, 6, 7, 8, 9 O's, and I have 4 AB's. And so in total, remember there were 25 Army inductees, I believe it said, yes. And so if I add 5 plus 7, 12, plus 9, 21, plus 4, 25. And so now I want to write the percent of each. And so if I take 5 divided by 25, and I divide that out in my calculator, I'm going to get 0.2, which gives you 20%. If I take 7 B's divided by 25, you're going to get 0.28, sorry about that, which gives you 28% people had type B. If I take 9 divided by 25 for type O and divide that out, that gives you 0.36 or 36%. And then 4 people out of 25 had type AB. When you divide that out, that gives you 0.16 or 16%. And if I add up my percents, generally they should add up to 100%, but sometimes they don't because you had to round. But if I add, I've got 48%, 20 plus 28, plus another 36 gives you 84%, plus 16% gives 100%. So this one added up to exactly 100%. So that is example 2.1 on page 43. So now I'm going to go to example 2.2 on page 47. And we're going to walk through that example for record high temperatures. So this one says, these data represent the record high temperatures in degrees Fahrenheit for each of 50 states. Construct a group frequency distribution for the data using 7 classes. So that's very important that it should have 7 classes in our group frequency distribution. So the first thing we have to determine is the highest data value, which if we look through the data turns out to be 134 degrees. And the lowest data value is 100 degrees. So then that means the range is high minus low, 134 minus 100, which gives me 34 for the range. And then taking that data, we do really which is the most important step, which is to find the class width. And the class width is our range divided by the number of classes, 7 in this case. And when we divide that out, we're going to get 34 divided by 7. Let me grab my calculator here. It's not going to come out evenly, which is going to give me 4.857 something. Doesn't come out evenly. And so what they say here is for the class width that you always are going to round up. And so we're just going to round that up. So our class width, the magic number in this problem, is going to be 5, because even if it was 4.2, we would round up. So our class width, the magic number in this problem, is 5. So whatever this number turns out to be, you round up to the next whole number, okay? And so now we're going to make our frequency distribution. And so we're going to use these columns. Let me grab another board here. We're going to use these columns for our frequency distribution. And so we're going to make a column called class limits. Class boundaries. We'll talk about that in a minute. We want to count them up, so the tally, and then using the tally we'll do frequency, as we did in the previous example. Okay, so again, going through this example 2.2 from page 47. So we start, the lowest data value was 100, if you recall from the previous example here. The lowest data value was 100. So we're going to start the first class at the lowest data value, which is 100. And we want 7 classes. So we're going to take that magic number of 5, the class width, and we're going to, these are called the lower class limits here for each class. We're just going to keep adding 5 until we get 7 classes. So adding 5, I get 105. Adding 5, 110. Adding 5, 115. Adding 5, 120. Adding 5, 125. Adding 5, 130. 1, 2, 3, 4, 5, 6, 7. All right. So the class limits should never overlap. So the second class starts at 105, the previous class has to end at 104, so it doesn't overlap. And notice that we don't have any gaps in our temperatures, and if you count from 100 to 104, it's 5 numbers, 100, 101, 102, 103, 104. And now we can just keep saying the third class starts at 110, so the previous class has to end at 109. Or we can just add the magic number of 5, the class width here. So if I add 5, I've got 114, 119, 124, 129, again adding 5, 134. And remember the highest data value was 134. And so all of our data is going to be included in those classes. Sometimes the highest the upper class limit of the highest class, the last class, is higher than the highest value, just how it works out. So our class boundaries have to end with one more decimal place than the original data. Our original data were whole numbers, and they have to end in a 5. So basically we're going to take the lower class limit of the first class, 100, and because they're whole numbers, we're going to have our class boundaries have 1 decimal place. Whole numbers have 0 decimal places. So on all of these lower class limits, I'm going to subtract 0.5 to get my lower class boundaries. So 100 minus 0.5, 99.5. 105 minus 0.5, 104.5. 110 minus 0.5, 109.5. And we can keep doing that, or we can take our magic number, the class width of 5, and now just add 5 to all these numbers. So 114.5, 119.5, 124.5, and 129.5. Those are all the lower class boundaries. We use the boundaries for our graphs that we're going to make in section 2.2. For the upper class boundaries, we're going to take the upper class limits and add 0.5. So then again, there's one more decimal place than in the original numbers, which had 0 decimal places. They were whole numbers, the original data. So 104 plus 0.5, 104.5. 109 plus 0.5, 109.5. 114 plus 0.5, 114.5. Or again, we can take our class width, the magic number of 5, and just keep adding 5 once we get our first numbers here. So if I add 5, I've got 119.5, I've got 124.5, 129.5, and 134.5. Notice the class boundaries, they do overlap because they are used for our graphs, and in our bar graphs, the bars should be touching, and in our line graphs, the lines should be continuous. So these class boundaries should overlap, and we'll use that for the graphs. And then we're going to do a tally. So we're going to go back to the original data, and there's a lot of data there. So I'm just going to get started with the first row and do a tally from the first row. But if we had gone through the whole process, we would go through all 50 data values and I'll just go through the first row. So the first row, there's 112. Where does that go? In the third class, 110 to 114. Then going across the first row. Next one is 100, that's here. So I'm just putting a tally mark to count it. Then 127, that's in this class. Still in the first row, 120 is in this class. Then 134, which is here. Then 118 in the first row goes here. Then 105, putting a mark here to count that. Then 110, that's in this third class. Then 109, which is in the second class. And then 112, which is in the third class, and so on. So if I went through all those 5 rows that each have 10 data values in it, and I went through the whole process of counting up all that data, and another way to do that would be to put the data in order and then count them up. In the end, just to take a little less time here, in the end, if we go through that whole process of counting the data, what ends up happening is that the first class will have 2, the second class will have 8, if I counted all the data, the third class will have 18, the next class has 13, again, if I count up all that data and go through that process, the next class has 7, the next class has 1, and the next class has 1. Now you want to make sure you've accounted for all 50 data values from that example 2.2 on page 47. So we've got 10, 28, 41, 48, 49, 50. So we know we did not overcount or undercount from any of the data here. Now we're going to use this example 2.2 from page 47 in example in section 2.2 so that we can make graphs from this example. And so there is one more example I want to go over in this section, which is example 2.3 on page 49. And example 2.3 on page 49 is asking us just to make a frequency distribution, or like we did before we had we had qualitative data in example 2.1, remember blood types? Well, now we've got quantitative data, and we really don't have that much data. The lowest data value is 5 and the highest one is 10, so we don't need to make a group frequency distribution for this data. We could just then make our data by using class limits and class boundaries for the graph. We can make our tally to count up the data and then the frequency. And the lowest data value was 5, 6, 7, 8, 9, 10. That was it only went from 5 to 10. And so for the class boundaries, again, you're going to use, it's going to end in 0.5, and it's going to be one more decimal place than the original data. And so we're going to take, we're going to subtract from 5, we're going to subtract 0.5 since it's a whole number, and that's going to give you 4.5. And from 6, we're going to subtract 0.5, which is going to give me 5.5. And from 7, we're going to subtract 0.5, which gives me 6.5. From 8, subtract 0.5, which gives me 7.5. Subtract 0.5 from 9 gives me 8.5. And subtract 0.5 from 10, which gives me 9.5. And I'm going to stop here and pick up on the next video to finish this one because my videos are limited to 15 minutes. So I'll stop here and then I'll pick up on the next video, this example.